understand the concept of voltage and current and resistance, let's analyze this question. It says the resistance of the voltmeter in the circuit diagram illustrated above is 800 ohms. Calculate the voltmeter reading. So this is the voltmeter here represented, and you see it's connected in parallel to this 800 ohms resistor. And then you see this 400 ohm resistor is in parallel with another 400 ohm resistor. So this voltmeter, what it will be reading is the voltage across this 800 ohms resistor. So we are to find the voltage reading across this 800 ohms resistor. So how to do this? How to do this is this. First, you know Ohm's law, V equals to IR. V equals to IR. So now you see that the same, if we calculate, we're going to calculate the equivalent resistance of the resistors in this circuit. R here will represent the equivalent resistance. Then we can call this one on top here R1, call this one below R2, and this other one here R3. Then R here will represent the equivalent resistance. Then I here will represent the total current coming from the cell. The total current coming from the cell. So how do we get the voltage across this R3? The voltage across this R3, let me label it V subscript 3. That voltage across R3 will be what? The current, which is I, times what? R3. So the current passing through this R3, this network, times the resistance, the value of the resistance will give you the voltage reading. So we are going to calculate the equivalent resistance R, use the equivalent resistance to calculate the equivalent current. That's the current coming from the battery. The current coming from the battery will be the same current that will flow through this 800. You know, when the current comes here, this parallel connection, it will share into two equally, and then when it comes back here, it will rejoin. So here is a series, like a series connection. Because this voltmeter is only taking reading of this resistance here. So the current, the total current that comes there will divide here between this R1, R2, and then rejoin here and then pass through this 800. So it is the current that pass through this 800 ohms will still be I. Will still be I. So first we are going to calculate equivalent resistance R. Equivalent resistance R will be 400 parallel 400. 400 parallel 400. These two that are in parallel will be in series with this 800 ohms resistor. 800 ohms resistor. So since there are two resistors in parallel, you can do it as 400 times 400 divided by 400 plus 400, then plus this 800 here. So I will not multiply out through there, but even if you want to multiply, that will be 16. That will be 16. How many zeros? 1, 2, 3, 4. That will be 160,000 divided by 400 plus 400 is 800 plus 800 here. So 0, these two zeros will cancel these two zeros. 8 will cancel itself 1. Cancel 16, 2. 2 times the two zeros there will give you 200. So you're left with 200 plus 800. So your equivalent resistance is what? 1000 ohms. 1000 ohms. So having gotten the equivalent resistance there, now our total current will be the voltage, the total voltage, which is the equivalent voltage here, that's 6 divided by the equivalent resistance. And our voltage there is 6 divided by 1000, which will give you in decimal 0.006 amps. 0.006 amps. In which, if you still convert it to standard form, that will be 6.0 times 10 raised by minus 3 amps. So now we've gotten our current. What is left now is to calculate V3. So our V3, that's the voltage across the voltmeter, across the 800 ohms resistor, which will be the reading of the voltmeter, will be equals to our equivalent current times the resistance there, which is R3. So this will be equals to, I'll use that of the fraction, 6/1000 times R. Our R is 800. So 2 zeros will cancel 2 zeros here, and then 2 will cancel here, 4. 2 cancel here, 5. 6 times 4 is 24 divided by 5, and 24 divided by 5 is 4 times remainder 4/5, which is 4.8. If you add 0 to that 4, that will be 4.8 volts. So the voltage reading on this voltmeter will be 4.8 volts. So if you were also asked to calculate the voltage across the parallel resistors, that's between point A and point, if I call this place point A and point B, if you were to calculate the voltage across here, what it will be, if you call the voltage across the parallel connection, will be the total voltage here, which is 6. The total voltage there, which is 6, minus the voltage drop on this 800, which is 4, which is 4.8. So that minus that will give you 1.2. To give you 1.2 volts. So the voltage across this parallel connection will be 1.2 volts, while the voltage across the 800 will be 4.8 volts. So that's how voltages are analyzed, as the total voltage that comes here, when it goes, each of these resistances will drop it, will reduce it. So this one will drop 1.2, and this second part here will drop 4.8. So what will be returning here, this data will now be 0 volts, and that's why the difference in potential that will make the current flow. All right, thank you.